wanted to graph the function f of x equals negative 3x plus 7. Give the domain and range. If I ask you to graph this, where do we start? 7. Remember that this is just a line. The negative 3 is your slope. The 7 is your y-intercept. So when you graph a line, you start with a point at the y-intercept. My slope is negative 3. So we go down 3 and over 1. Or you could go up 3 and backwards 1 if you wanted. Okay, so then just draw a line connecting the two. Hopefully your lines are a little bit straighter than mine. Corbin, that handout is for tomorrow. I didn't give out one for today. This one's just in your notebook. I'm sorry about that. Is this line increasing or decreasing? Decreasing. As you go from left to right, the line is falling. What makes it decreasing? Right. Positive slopes increase, negative slopes decrease. Domain. It's talking about my x. As I go from left to right, this is extending forever in the negative and the positive direction, so eventually we would hit the range. This piece goes down forever, this piece goes up forever, so we hit everything. Every line will have a domain and range of negative infinity to infinity, except horizontal and vertical lines. Otherwise, those will always be the same. Questions there? Do I need to graph another one? Let's do just a couple variations. I want to make sure we're okay with those before I move on. Okay. If it is x equals, what kind of line do we have? Vertical. X equals is a vertical line. If you were confused, you would just make an order pair, or make a t-chart, and the only thing x can be is negative 3. So you would see your x has never changed. So it's a vertical line. So x equals negative 3 is a vertical line. Is that one a function? Now it fails the vertical line test. What's the domain of that? Negative 3. We only hit a single x value, so we can't even write that in an interval. That is the only thing. What about the range? Right. Keeps going down forever and up forever, so it's negative infinity to infinity. What if I said f of x equals negative 3? F of x is the same as y. So that's like y equals negative 3, so what's that look like? X equals is vertical, y equals the number is horizontal. What's the domain of that one? Domain is talking about your x, so as you go from left to right, this goes forever in both directions. So we hit everything. range is referring to my y's, or we could think going from the bottom up, what's the only thing we hit? Negative. Just a single y value. Alright. So far, so good? We might see our lines in standard form. That's ax plus by equals c. In that, there are some stipulations. A, B, and C have to be integers. So that means no fractions, no decimals. A has to be a positive number. And their greatest common factor has to be a 1. In other words, if they were all even, you would need to divide everything by 2. That down. So if I give you something in standard form and ask you to graph it, what do we do? Is it easy to graph when it's written like this? Not especially. What would make it easier? Yeah. Change it to y equals mx plus b form. Solve for your y. So if we subtract our 3x, divide by 4, y is negative 3/4x. Then we can easily graph that. It's a line. The y-intercept there is 0. Slope 3/4, so go down 3 over 4, or you could think of it as up 3 and backwards 4, however you want. What's the domain? As long as it's not horizontal and vertical, domain and range are always both negative infinity to positive infinity because it keeps extending in both directions. There? Do we need another one like that that's in standard form and we have to graph? Graph that. So in y equals mx plus b, you have y equals 4/5 x. So I gave you another one with the y-intercept of 0, up 4, over 5. What are domain and range? negative infinity, positive infinity. Okay. We're not even writing the equations today. We're just talking about graphing. We'll do equations tomorrow. So when I talk about slope, that's the steepness of a line. On the graph, we think rise over run. The equation, I know that looks a little funny when I was typing, my subscripts kind of changed. It's change in x over change in y, so y2 sub 2 minus y sub 1 over x sub 2 minus x sub 1. If I am looking at a line, does it matter which 2 points on it I use to find the slope? No, the slope is the same no matter which 2 points you pick on your line. What is the slope of a vertical line? Undefined. Horizontal line has a slope of 0. Good. We know that if we are looking at the equation, the slope is your m. If I said like y equals 5x minus 4, what's your slope? Y equals 5x minus 4. 5. Just the m. If it has a positive slope, then that's increasing, and negative slope would be decreasing. What kind of line would be constant? Horizontal lines are constant. Okay. Oops, that's not what I want to do. Let's find the slope between 2 points. So it doesn't matter what you use for your x1, but you just have to make sure your y1 comes from the same ordered pair. And our slope, we just wrote down our formula, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. You guys do B and C for me. Do you get 0 for B? And then part C. Get 20 over 0, which means undefined. What kind of line is that? Vertical. Good. The very last example I want to do. If I ask you to find average rate of change, what am I asking for? Slope. Average rate of change is just another word for slope. So we'll just do one example of this and then we're done. In 1997, sales of VCRs numbered 1.6 million. In 2002, sales were 13.3 million. Find the average rate of change. So when I ask for average rate of change, I'm asking for slope. We have to write this information as ordered pairs. So in 1997, what would my y be? And second order pair would be 2002, comma 13.2. So y sub 2 minus y sub 1 over x sub 2 over x sub 1 I'm going to write this as a fraction. You could, of course, give me a decimal. On an average rate of change problem, I would like units on your answer. So think about how we found this answer. We did y over x. What were the units on my y's? Million. What were my x's? Years. So being million per year. What's the negative telling me? Going down. It's decreasing that much every year. Any questions? So we've got some time left. Hold on, I think I'm going to modify this, actually. Don't write that down yet. I want you to do there are a couple sections, this looks like a lot of problems, but there are some matching problems and things in here, so those go pretty quickly. This will be due tomorrow. Obviously, you guys do it between the next time I see you, and then tomorrow I'm teaching section 5, which is just writing the equations, and you have the notes.